If you ever have the chance to stand beneath the dome of the Pantheon, you'd find it hard to believe that this structure is nearly 2,000 years old. Looking toward the Spanish coast, you can still see the Lighthouse of Hercules continuing its mission of guiding ships as it has for centuries. Even more surprising is that many other Roman structures have outlived most modern buildings. This paradox has led scientists, engineers, and historians to constantly ask the same question. What enabled the Romans to build structures that could withstand the test of time for so long? The answer doesn't lie in magic, nor does it lie in lost supernatural mysteries. Behind the walls that have stood for millennia lies a system of engineering, materials, and construction methods far ahead of its time. And to understand that secret, we must begin with the foundations that made Rome the most powerful empire of the ancient world. To understand why the Romans were able to build structures that have lasted for thousands of years, we first need to look at the foundation that built the empire's strength. Many people often think that Rome became a superpower because of its formidable armies. But in reality, Rome's strength didn't begin with its military. That strength began with its infrastructure. The Romans understood that no city could thrive and no structure could be built if materials could not be transported to the right places. Therefore, from a very early stage, they invested heavily in a vast transportation network spanning the entire territory. Over time, these roads connected cities, seaports, quarries, timber yards, and important administrative centers into a unified system. What made the Roman road system special was the way the Romans approached the terrain. Instead of taking detours to avoid difficulties, Roman engineers often chose the straightest routes possible. Their roads cut through hills and mountains, crossed dense forests, and connected distant areas with direct lines of communication. This method significantly shortened travel time and increased transportation efficiency. The durability of Roman roads was no accident. Each road was typically constructed using multiple layers of different materials. At the bottom was a layer of large stones providing stability to the entire structure. Above the stones was a layer of crushed stone that distributed the load. Next was a cushioning layer that leveled the surface and aided drainage. On top was the finished road surface, made of solid slabs of stone. This multi-layered structure allowed the road to withstand heavy traffic and last for a very long time. These roads served not only for military movement, they were also the lifeblood of Roman construction. Huge blocks of stone from quarries were transported to construction sites. Timber from distant forests was brought to urban centers. A wide variety of other building materials also constantly moved along this transportation network to serve large-scale projects. It was thanks to this efficient transportation system that the Romans were able to concentrate resources from many different territories on a single project. Before building the colossal bridges, massive amphitheaters, or famous domes, the Romans had already built a robust infrastructure network to support all the construction sites. In other words, great constructions are not the starting point of an empire. They are the result of a foundation that has been prepared beforehand. And that foundation is the infrastructure, the invisible framework that enabled the entire Roman Empire to function and develop for centuries. However, roads, however important, only solved part of the development problem. Transportation infrastructure could bring materials to construction sites and connect territories, but for cities to truly develop into densely populated and prosperous centers, the Romans had to address a much greater challenge: the issue of water. For most ancient cities, water resources were always a difficult natural limitation to overcome. As the population increased, so did the demand for water for daily life, sanitation, and production. Many settlements could not expand simply because the local water sources were insufficient. This was an obstacle that almost every ancient civilization faced. The Romans found a revolutionary solution. They built aqueducts, or large-scale aqueduct systems, to bring water from distant sources to urban centers. Instead of relying entirely on rivers and lakes near the city, the Romans actively sought out stable water sources in mountainous regions or areas with better water quality, then transported this water through conduits tens, even hundreds of kilometers long. Remarkably, most aqueducts operated by gravity. To achieve this, Roman engineers had to maintain an extremely small but precise slope along the entire length of the structure. If the slope was too steep, the water flow could damage the structure. If the slope was too shallow, the water would not be able to flow effectively. Controlling error over such enormous distances was a remarkable engineering achievement for that era. When water was brought to the city, the Romans used this precious resource for many purposes. Public baths received a constant supply to serve thousands of people each day. Fountains were placed in many areas to provide convenient water for residents. Households, residential areas, and many other public buildings also benefited from this distribution system. Water is essential not only for daily life, but also for construction. Construction sites need water for mixing mortar, producing concrete, and carrying out various other construction processes. As construction projects expand, the need for a stable water supply becomes more crucial than ever. The Romans understood a very simple but extremely important principle. To make concrete, you need water. To build enormous cities, you need water. And to sustain a vast empire, you also need water. Therefore, the aqueduct was not just an engineering feat. The water system was the lifeblood of Rome, silently sustaining cities, supporting construction sites, and enabling the empire to develop far beyond the limits many other civilizations had ever reached. And with such a robust transportation infrastructure and abundant water resources, the Romans began to make the next breakthrough in the art of construction. Having built an extensive transportation network and secured a stable water supply for their cities, the Romans possessed advantages that few other ancient civilizations had. However, materials and resources were only part of the story. To create structures far exceeding contemporary standards, the Romans needed a crucial breakthrough in the way they designed and supported their buildings. That breakthrough came from arches and domes. The Romans were not the first to invent the arch. Several civilizations had used this principle in construction before them. However, the Romans perfected the technique, applying it on a large scale and making it the foundation of imperial architecture. In many ancient structures, the framework relied on horizontal beams supported by columns. This method worked effectively when the spacing was not too large. However, as the structure expanded, the horizontal beams faced increasing pressure and were prone to cracking. This created a natural limitation on the width and scale of the structures. Arches solve this problem in a completely different way. Instead of concentrating all the load at one point, arches distribute the force to both sides and transfer it down to the foundation. Thanks to this mechanism, the stone blocks within the arch can support each other and create a much more stable structure. The load-bearing capacity of arches is superior to traditional horizontal beams, allowing engineers to build larger structures while maintaining high durability. The Romans quickly applied this principle to bridge construction. Famous bridges like the Limyra Bridge and the Trajan Bridge demonstrate their incredible engineering prowess. By using multiple consecutive arch spans, Roman engineers were able to cross vast distances without relying on overly massive structures. This resulted in bridges that were both longer and more stable than most structures of the time. Thanks to their efficient load-bearing capacity, many Roman bridges have survived for centuries, defying natural disasters, wars, and the ravages of time. This is clear evidence of the effectiveness of the new construction thinking that the Romans developed. From the arch, the Romans further expanded this idea to create domes. The most iconic example is the Pantheon. With its famous enormous dome, the Pantheon created a vast interior space without the need for many supporting columns. What was previously almost impossible with traditional construction methods became a reality thanks to its clever load distribution. This wasn't simply a technical innovation. It was a revolution in structural thinking. The Romans completely changed how people understood building structures, opening up the possibility of constructing larger, more durable, and more ambitious spaces than anything the ancient world had ever seen. But to turn those bold designs into reality, they still needed another crucial element: construction machinery. The colossal arches and massive bridges often raise a question: how did the Romans manage to lift massive blocks of stone, weighing tons to such heights, and assemble them with such incredible precision? Many imagine that everything was done entirely by human strength. However, That is an incomplete understanding of Roman construction techniques. In fact, the Romans didn't rely solely on manual labor." End quote. End quote. They also used a variety of machinery and mechanical devices to increase productivity. These technologies enabled them to undertake construction projects on a scale that many other civilizations could hardly achieve. One of the most famous pieces of equipment is the trispastos crane. This system uses multiple pulleys to significantly reduce the force required when lifting heavy objects. Thanks to its simple yet effective mechanical principle, a small number of workers can lift blocks of stone weighing far more than they could lift directly by hand. The Romans also developed more advanced systems, such as the polyspastos. With a greater number of pulleys and better force distribution, this device helped lift extremely heavy materials for the construction of temples, bridges, and large-scale public works. These pulley systems became invaluable tools for Roman engineers and builders. Besides lifting and hoisting technology, the Romans also applied mechanization to the material processing process. A notable example is the water-powered stone cutter discovered at Hierapolis. This device harnessed energy from the water flow to operate the cutting blade, making stone processing more efficient than traditional manual methods. This is evidence that the Romans knew how to utilize natural energy sources to support production. Equally important to the machinery was their organization of labor. Instead of having one group of people perform every task, the Romans divided the work into specialized teams. There were teams for quarrying stone, transportation, material processing, and direct construction. Each department was responsible for a specific task within a clearly organized process. The combination of machinery, mechanical systems, and specialized labor created an incredibly efficient construction system. This wasn't simply about mobilizing large numbers of workers. It was a rudimentary form of construction industry, where technology and organizational production worked together to create structures far beyond the capabilities of mere manual labor. But even the best machines would be useless if the building materials weren't durable enough to withstand the test of time. Stone lifting machines, pulley systems, and efficient labor organization processes enabled the Romans to build colossal structures. However, all that technology would be meaningless if the building materials weren't durable enough to withstand the test of time. And this is where we uncover the most important secret behind the longevity of Roman structures: Roman concrete. For centuries, researchers have wondered why Roman harbors, bridges, temples, and domes have survived for nearly 2,000 years. The answer lies in the type of material they used to bind the entire structure together. The basic composition of Roman concrete was relatively simple. The Romans mixed lime with volcanic ash and crushed stone to create a material with exceptionally high strength. Volcanic ash played a crucial role in this process because it created chemical reactions that helped the concrete become increasingly stable over time. However, modern research has uncovered a surprising detail. In many samples of ancient concrete, scientists have found small fragments of white lime scattered within the material. Previously, many believed this was simply a sign of an imperfect manufacturing process. But subsequent studies suggest that these lime fragments may have been an important part of the mechanism that allowed Roman concrete to self-heal. This mechanism works in a rather unique way. When a small crack appears and water begins to seep inside, the lime particles react with the water. This reaction allows new minerals to form inside the crack. Over time, these minerals gradually fill the void and help restore part of the material's original structure. In other words, instead of simply deteriorating over time, Roman concrete had the ability to self-repair some minor damage before it developed into serious cracks. This was a very rare characteristic in ancient building materials. This difference becomes even more apparent when compared to many modern types of concrete. In many cases, modern concrete gradually degrades as water and environmental elements penetrate the structure. Conversely, Roman concrete, under certain conditions, can trigger reactions that extend its lifespan. That's why many Roman structures have stood for thousands of years. The Romans not only built with ingenious techniques, but also possessed a special type of material that modern science is still studying and learning from. And looking back at the whole story, we realize that the greatest achievement of Rome wasn't in any single technology, but in how they combined all those elements into a complete system. Looking back at the whole story, we can realize that the Pantheon, the Colosseum, or the Lighthouse of Hercules are not the most amazing things the Romans left behind. What is truly amazing lies in their systemic thinking. The Romans did not rely on a single invention. They combined transportation, infrastructure, water systems, mechanical machinery, architectural techniques, and building materials into a complete network. Each component supported the others. It was this combination that created structures capable of lasting for thousands of years. Perhaps this is also an important lesson for people today. We live in an era that constantly demands quick results and instant success. But things of lasting value are often not created in a single day. A sustainable career is built on knowledge, discipline, and perseverance. A happy family is built on daily care. A memorable life is also created from small choices repeated over many years. The Romans didn't build the Pantheon first and then think about the foundation. They laid the foundation first so the structure could last for thousands of years. Our lives are the same. What we do today may not produce immediate results, but it determines where we will be in 10, 20, or even a lifetime. 2,000 years have passed, but those walls still stand. Not only as historical monuments, but also as a reminder that things that endure always begin with carefully constructed foundations. If this story makes you think, please share in the comments. What is the most important foundation you are building for your future? And don't forget to subscribe to the channel to discover more valuable lessons that history continues to silently tell us today.